Hello everyone, today we're looking at Unit 4, Lesson 7, Modeling Using Quadratics. So we're going to take what we've learned about the key points of a quadratic and apply them to word problems basically, and try to interpret what is being asked of us in a word problem based again on those key points. So we'll have two examples to look at today. The first one, a rocket is shot into the air from a launch pad. Its path can be modeled by h equals -2 times t minus 4 squared plus 72, where h is our height in meters and t is our time in seconds. So we're not going to draw all of this right now, but we're just going to start drawing a graph to begin discussing what's being represented here. So we'll only draw the positive side of the graph because if we're talking about a real life example, generally we're not going to have negative values, especially when we're talking about height and time. So you can see where my y value usually goes, I have h for my height. So that means height's going to go on our y-axis. So I'm going to put an h up here. And it says height is in meters. So I'll say that our height is in meters. And where our x usually goes in the equation, we have a t, and t represents our time in seconds. I'm just put seconds there. So we've been given a model or an equation here that's in vertex form, so we can identify some of these things. We know that our vertex comes from the h and the k in vertex form, so we could say that our vertex is at positive 472. Remember, we switched the sign on the x value. So let's just plot that. We would go 472, something like that. We're not too sure what. We know a few other things, okay? Our a value is a -2, so our parabola is going to open down. Right? Our parabola is going to open down. So we can draw this parabola as if it's opening down. We don't really know where it's going right now, but we can just do a rough sketch and maybe we can label some of these points later. So the first question is, what is the maximum height the rocket reaches? So again, our height, it represents our y value, okay, and we have a maximum at our vertex. So our height is going to be 72 meters. So we can say, therefore, the max height is 72 meters. After how many seconds does the rocket reach its maximum height? Okay, well, that's going to be the x part of our vertex because our x is represented by time. So after 4 seconds, the rocket reaches its maximum height. Okay, the next question is, how high is our launch pad? So remember that the rocket is shot from our launch pad. So let's say that we have, I don't know, some pad here that it's launching from. Okay, well, that point on our vertex is represented by the y-intercept because it's where the parabola is crossing the y-axis. So when it says how high is the launch pad, we should be thinking initial value. So really, what is the y-intercept? So to find our y-intercept, remember that our y-intercept happens where x is equal to 0. So we're going to set, in this case, our t value is what usually is our x value. So we're going to set time equal to 0 and solve for our height. Because also remember, where it's initially launched from, the time is 0, right? When we're initially launching the rocket, we haven't started recording any time yet. So our time is 0 at that point. So we're going to take our equation and we're going to sub in 0 for t. Okay, and we'll get a -4 squared plus 72. So this will be 16. Making sure that we do order of operations correctly. -2 times 16 is a -32 plus 72. So our height equals 40. So we can say, therefore, the launch pad height is 40 meters. Okay, and we can label that point now too. We know that this point here at our y-intercept is going to be 0 and 40. That's our y-intercept. Okay, when does the rocket hit the ground? So if we look on our parabola again, well, the rocket's going to hit the ground somewhere here. And hopefully we can identify, well, what is that key point called on our parabola? And even though it's not going to be relevant to be negative, we can identify both of them. Right? So hitting the ground is where it's crossing our x-intercept. So we need to find our zeros. So really, what are the zeros? For this relation. And same idea here, our x-intercepts are going to be where our y value is 0. So we're going to now set h equal to 0 and solve for time. So we'll plug in a 0 where we had h. And we'll use algebra to solve. So I'm going to move 72 over by subtracting it. I'm going to divide both sides by -2, so we'll get 36 equals t minus 4 squared. Okay, now we're going to have to take the square root of both sides to get rid of that power of 2. And remember, when we take the square root, the answer is going to be the plus and minus version of whatever that square root is. So now we will have two answers that we're working to solve for. We're going to have t minus 4 equals positive 6 and t minus 4 equals negative 6. So we'll add 4 to both sides, so we get 10. Or if we add 4 over here, we're going to get negative 2. Now, as we said before, we're not going to take a negative amount of time, so we can just say that that one's not possible. So therefore, the rocket hits the ground after 10 seconds. So we could label these zeros up here now. We know that this is 10, 0, and this one over here, even though it's not realistic, it would be negative 2, 0. So you can see by going through these different questions of a word problem, we're really just identifying those key points that we've been talking about with the parabola throughout this unit. Okay, let's look at one more example. This time they're going to give us the equation in standard form. So we'll have to think about what information we can get from standard form and what form we might have to change it to answer some of these other questions. So it says a ball is thrown upwards from a balcony. The ball follows a path modeled by h equals negative d squared plus 7d plus 8. H is the ball's height in meters, and d is the ball's horizontal distance in meters. So if we think about a graph again, okay, our y-axis is again represented by height, and it's going to be in meters. Our x-axis this time is our horizontal distance. So think about if you were throwing a ball, how far horizontally it's going basically as you throw it. That's what's represented by our horizontal distance. So I'm just going to put a D for distance. And this is also represented in meters. Okay, they gave it to us in standard form. So some of the things we can identify here, our A value is a -1, so that tells us it's going to open down. And then we also have, when we're in standard form, our C is our y-intercept, remember. So if we wanted to start graphing our parabola, there's not much we know other than our y-intercept is going to be at 8, so 0, 8. So we might be able to use that, but we'll continue going through these questions and see if we can convert it where we need to find some other information. So part A says let's convert the quadratic equation into factored form. So the first thing we're going to do, we don't want that negative on my d squared, so we're going to common factor out a -1. Just so that we can have a positive d squared here. I'm going to take out a -1, so we'll be left with d squared minus 7d minus 8. Now I have a simple trinomial I can factor. So I'll set up my SPF. Okay, I need two numbers that add to a -7 and multiply to a -8. So that's going to work out to be -8 and plus 1. So we'll have d minus 8 and d plus 1. Okay, so in factored form, we can hopefully find some more useful information to actually graph this parabola and see what it looks like. So at what horizontal distance does the ball hit the ground? So remember, if we're hitting the ground, we're trying to figure out what are those zeros, right? Where does that parabola hit the x-intercept? So what are the zeros? And because we got it in factored form in that last question, we can just take our factors or take our brackets, set them equal to 0, and solve for d. So we'll have d equals 8 and d equals -1. Again, if our ball is moving forward, then this one is not probable, so we reject it. So we can say, therefore, the distance is 8 meters when the ball hits the ground. So knowing that, we can label our zeros. So we know we're going to have 1, 0, 8, 0, and we're going to have one at -1, 0, even though that one's not one that we're going to consider possible for this word problem. At what horizontal distance does the ball reach its maximum? So when we see maximum or minimum, we should be thinking vertex. And if it's asking at what horizontal distance, well, this is the x is an x value. So it's going to be the x value of our vertex, which is also our axis of symmetry. So to find our axis of symmetry, we're going to take the midpoint of our zeros. Okay, so we're going to have x of our vertex is going to equal 8 plus -1 divided by 2. Okay, 8 plus -1 is 7. 7 divided by 2 is 3.5. We'll use a decimal for this. Okay, so the horizontal distance, or the distance, is 3.5 meters when the ball reaches its maximum height. So that's part of our vertex, but it's not all of it. So we're going to hold up on actually graphing what that is. So what is the ball's maximum height? So this part is the y value of our vertex. So we're going to sub in the x value we just found, which is 3.5. I'm going to sub it into my factored form because it's just easier to work with. So we'll have 3.5 minus 8 and 3.5 plus 1. So this will be a -4.5 times a positive 4.5. So when we calculate or multiply all those, we're going to get a height of 20.25. Okay, and this represents the y value of our vertex. We've given the y value a different variable. We're calling it the height in this scenario, but that's still the y value of our vertex. So we can say that our vertex is at 3.5 and 20.25. And we'll answer the question as well. So therefore, the max height is 20.25 meters. Now we can plot that vertex. So we have a vertex somewhere around 3 and 20.5. Or sorry, 3.5 and 20.25. Okay, we can see what's going on hopefully with our dots here, but we also know from our A value that this parabola is going to open down. So the parabola should look something like that. Okay, and it says what height is the balcony? Well, that again is our y-intercept, because that is where the ball initially starts from. It's where it's thrown from. So we are identified our y-intercept as 8 meters. Okay, so the balcony is 8 meters high. So therefore, 8 meters high. Okay, we'll continue looking at word problems, but that's all for your note for today.